Hello everyone. My name is Thomas Kim. Today is March 16th, 2023. This is my 26th episode for C++ electricity magnetism with vector calculus classical physics. This is my 7th episode about SYCL. In this episode, I will discuss Recursive Device Function, SDD shared PTR as a SYCL buffer memory. I like CUDA, but I like SYCL as much. SYCL, as of today, has two serious drawbacks. A. SYCL capable devices from Intel, such as Xe, HPG, or Intel Arc A series graphics devices do not yet support double precision operations. This problem is very likely to be resolved after one or two more generations of the Intel GPU devices later. In this document, oneAPI GPU optimization guide, double-click it. If you scroll down, Intel Iris Xe GPU architecture. Here, you can read the specification. In case of Intel Iris Xe LP, LP means lower power or integrated GPU, support floating point 32 but does not support floating point 64 or double precision. If you scroll down, you can read this part. An Xe core of Xe HPC GPU contains blah blah blah. The Xe core delivers 512 floating point 16, 256 floating point 32, 256 floating point 64 operations. It means Xe HPC GPU support double precision operations. However, if you scroll down here, Xe HPG GPU, here the Xe core delivers 256 FP32 operations. It means 32-bit floating point operations. But this device, HPG GPU, does not yet support FP64 operations. I mean, Intel A-series GPUs does not yet support 64-bit floating point operations. Since HPC, Xe HPC GPU support floating point 64, it is very likely after one or two more generations later, Intel desktop GPUs will also support 64-bit floating point operations. There is another very serious problem. Problem B, SYCL 2020 specification does not allow runtime recursion in the kernel function. SYCL 2020 specification revision 6. In this link, if you search for recursion, recursion is not allowed in a device function. So, recursion is not allowed in SYCL 2020 specification. Problem A. Double precision support will be resolved one or two more generations later. SYCL 2020 specification stipulates recursion is not allowed in a device function. I figured out how to overcome this problem. I mean, how to work around runtime recursion limitation of a SYCL device. If you watch through my video, you can learn how to overcome recursion is not allowed in a device function problem. I will also discuss how to use shared PTR. I assume you have watched my previous video listed here from episode 25, SYCL 6. Please double click it. I assume you have watched my previous videos about SYCL in this playlist. Otherwise, it might be difficult to follow my current session. Show more source code after filming video. Click this link. Show in folder, unzip it. Rename 26. Recursion. Copy, paste it in your working directory. Open up Visual Studio Code, Electricity Magnetism from folder 26. Copy, paste. Rename Recursion. Ctrl V. I will close these things. Now I will briefly explain how to use shared PTR. Void test shared PTR. Int main, copy the function name, paste it here. For more information about shared PTR, please Ctrl-click this link. Shared PTR was first introduced to C++11 standard. This shared PTR has been upgraded in C++17, also in C++20. C++17 standard or SPTR1 STD shared PTR int 5 new int 5. In C++17, array is allowed for shared PTR or L-value reference S1 CPT cast pointer to array. We can pass 5, then SPTR1 cat. We can retrieve pointer from shared PTR using member function cat. Then std cout s1 equals s1 cpg and there. Now C++20 standard. I will copy these, paste it here, SPR2. Since C++20 standard, we can now initialize the dynamic allocation of array like this. This is S2, now 2, then S2, S2. I will not discuss much about shared PTR, but this short introduction can be useful. CD 026 Recursion ICXCL QSDD C++20 EHSC FSYCL recursion.cpp oi.exe hit enter. CLS I. So in C++17 we can specify arrays for shared PTR, but we could not initialize like this. In C++17 it does not work. Since C++20 we can now initialize arrays using curly brace. So this is initialized. This is uninitialized. I also introduced cast pointer to array. The internal of this function is very simple. I simply use reinterpret cast, or you can reinterpret arbitrarily. For example, I will make it 10, 10. Then the same shadow PTR can be reinterpreted like this. 3, then 2. Copy, paste. It can be 3, 3. Now we rebuild CLSI. Now S3 is 1, 2, 3, 4, 5. 5 by 2 matrix. So using shared PTR and cast pointer to array is very useful. Now I will fold it up. How to convert runtime recursion to compile time recursion into runtime recursion int n. If n less than 2, return n, else return n plus runtime recursion n minus 1. Now I copy exactly the same function. Now I change it into compile time recursion. How? Template into depth 0 into max depth. For example, 20. Now, if context per depth greater than or equal to max depth, then we simply return n. Else, we are in the else block. Here, we are calling compile time recursion, but depth plus 1. This is runtime recursion. This is compile time recursion. They are semantically exactly the same. For the test, compile time recursion. Copy this function name, paste it here. Disable it. Auto R. Runtime recursion 10. Auto C. Compile time recursion 10. SED C out. Runtime R CPG and there copy paste compile time. This is C and L. Now we rebuild result is exactly the same. Why I created compile time recursion? You will see shortly. SYCL Q SED cout device Q get device CPG and L or shared PTR std make shared int 0. I created a shared PTR. SYCL buffer shared buffer. We pass this shared PTR here. It is not array, it is single element. So SYCL range 1 single element. We already allocated memory, shared memory on CPU or host memory. We instruct SYCL not to create host memory. SYCL property buffer use host PDR. It instructs not to create host memory. Use existing shared PTR memory. Semicolon. Auto comment group. We capture by reference. SYCL handler. Command group handler. This is lambda. Q submit. We submit this command group here. Now we create accessor. SYCL accessor S. We pass shared buffer. Then this command group handler here. We created accessor. Now auto kernel. We capture by value. We do not need to provide argument here. So we can remove this parenthesis. Then S. This S represent our shared buffer. This shared buffer represent our shared PTR. Now it is array, so we can put 0. We call runtime recursion like this. We pass 10. It does not work because we are using runtime recursion. Anyway, let's try. Then using command group handler single task, because we are using a single element. shared PTR has single element, not array. We pass kernel like this. Now here SYCL host access. I say HA bypassing shared buffer. We can use SYCL read only. Now std cout shared ptr. It is pointer semantic, so we can simply say shared ptr cpg and there. Now we build. It should not build. Error. SYCL kernel cannot call recursive function. This line causes the error. Okay, it is error. Now copy this, paste. We can call compile time recursion. With this, we build again. Amazing. Amazing. I effectively translated runtime recursion to compile time recursion. This is just simple demo, but by applying this technique, we can use recursion in our SYCL program in a device function. SYCL 2020 specification says recursion is not allowed in a device function. But as you just witnessed, we converted runtime recursion to compile time recursion, then used in the SYCL kernel.